Hello, are you building serverless applications and want to understand how networking security works? Are you wondering how you could actually add perimeter protection, add deeper networking controls, and also gain better visibility of your network traffic? Well, you're in the right place, in the right session. My name is Alex Tomic, and I'm an AWS Solutions Architect. Welcome to Security 322, Network Security for Serverless Workloads. I'm really excited to talk to you about network security for serverless workloads, and it's a topic that I frequently discuss with my customers. Follow me in this deep dive because we will use a sample serverless architecture to illustrate how you can add layers of additional control and tightly control network traffic, and also gain deeper visibility into that network traffic. So let's jump right in. So first section, let's look at how serverless architecture principles can improve your security posture. If you're working with serverless architectures already, this will appear as a very common pattern for a public-facing API. Users on the public internet make calls to APIs that you have defined in an Amazon API Gateway instance. API Gateway processes those API calls and in turn invokes Lambda functions, which execute your custom code and then interact with other AWS services. And throughout this presentation, we will build additional layers of control and security on top of this architecture. And first, let's look at how a serverless architecture, just like the one that you're looking at on screen, can improve your security posture. All right, I'll assume that you're familiar with the shared responsibility model. And below is the shared responsibility model for infrastructure services, such as Amazon EC2, where you launch virtual machines and then you own and operate all the components inside of those VMs. However, as you adopt serverless architecture services like AWS Lambda, know that how shared responsibility model changes for AWS Lambda. More of the components become AWS responsibility, and less security work has to be done by you. Serverless architecture allows you to offload that undifferentiated heavy lifting in security to AWS, while you focus on security components that are truly specific to your application. Okay, so how does Lambda shrink the attack surface? There are two primary ways. First, the execution environment is ephemeral, and any function can only execute for a maximum of only 15 minutes. And even the execution environment total lifetime is also measured in minutes. Another way that we shrink the attack surface is that the function does not need to receive any inbound network traffic. So no network traffic and no firewall rules need to allow traffic to the Lambda function. Now, AWS Lambda service also creates strong isolation boundaries between all functions. Execution environments are never shared across functions, and micro VMs are never shared across AWS accounts. So this illustration depicts Lambda isolation using Firecracker, which is a micro VM technology. Even if you have 1,000 functions executing in parallel, if they're using Firecracker isolation model, each function would run in its own micro VM. That strong isolation boundary extends to the networking stack. And we'll dive deeper into how to control that network traffic a little bit later in this session. Now, going back to a shared responsibility model, from that perspective, know that all parts of the infrastructure that you see on this diagram are AWS responsibility, except for that code that you bring to the function. So security, hardening, and compliance audit of all other elements are managed by AWS. So you can focus on the custom logic that is in your code. So going back to our serverless architecture, you can know that just by deploying this application in AWS, you benefit from network architecture that was built to meet the requirements of the most security-sensitive organizations in the world. And those standard controls that are part of serverless architecture are great, but what if your organization had very specific requirements how your users can reach your application? Well, that's what next section is starting to talk about. Let's start adding layers of control, improving perimeter protection. Our API is hosted in an AWS region, but are there ways to protect it before the traffic even reaches an AWS region? Well, let's talk about services that run in AWS edge locations that are available to protect public-facing APIs. These services are not hosted within any AWS region, but instead they are hosted in edge locations that are part of AWS network located closer to end users. These services can add layers of protection for public-facing APIs, so we're going to take a closer look on those. So what are some of the services hosted in these edge locations? We'll discuss 3 of those services here: AWS Shield, AWS WAF, and Amazon CloudFront. These 3 services can be combined together to add perimeter protection and filter out unwanted requests from ever reaching your application. In this case, that application would be your API hosted in an AWS region. Now, these services can take advantage of 200 plus edge locations spread around the world to get closer to consumers. Now, a quick note here, the diagram that you're looking at represents logical layers in AWS services. This is not a physical layout or data flow. Going back to kind of how our traffic is flowing here, since our API is public-facing, we are bound to have a lot of legitimate users and sending legitimate network traffic. But there is also a chance that malicious systems and malicious users would attempt to send unwanted traffic as well. So for example, this could be volumetric DDoS attacks. AWS Shield is a service that provides DDoS protection against layer 3 and layer 4 attacks. AWS Shield Standard is available at no cost to all AWS customers, and AWS Shield Advanced is available for more customized DDoS protection and more sophisticated DDoS attacks. Next, we have AWS WAF service, which provides a layer 7 protection against attacks such as SQL injection and cross-site scripting. We'll take a closer look at rules available with the WAF service. And then finally, we'll have CloudFront, which is a CDN service that comes with its own security controls. And we'll look at some of those controls shortly. So these 3 services, you can see, are closely integrated and provide powerful perimeter protection for applications hosted inside of the AWS regions. Let's take a closer look at a few of those services. What is AWS WAF? It is a web application firewall that helps protect your web applications or APIs against common web exploits. Each incoming request is inspected, then allowed or blocked based on the rules. And one of the differentiating qualities of AWS WAF is that it allows developers to build highly customized rules that closely fit your API or web applications. Now, you can build those rules using the console interface, which makes it really easy to build rules. And we have an example here that the rule that allows access from a specific set of IP ranges, or IP set as we call it in AWS WAF. Now, you can also declare rules using JSON documents. That enables creation of more complex rules, and also it allows for integration with your source control following the infrastructure as code principles. This JSON document that you see on the right-hand side is the same one as the rule that we built in the console on the left side, and they're both allowing access from an IP set. In addition to building your own custom rules, what about if you need to use the rules that are built by web security experts? AWS WAF provides us managed rules, and for that we have multiple options. AWS managed rule groups are available at no additional cost to AWS WAF customers, and those are continuously updated based on AWS's own threat intelligence. You can also choose from managed rules that are provided in AWS Marketplace by some of the top vendors in the application security field. All right, so why would you use a CDN like Amazon CloudFront for a public-facing API? Well, using CloudFront has security and performance benefits for APIs. To get the best amount of control, you can choose to create a regional API endpoint and when defining it inside of the API gateway configuration. You can then use that regional endpoint as the origin for your own custom CloudFront distribution. So CloudFront has some interesting security controls available. So for example, CloudFront configuration drives how edge locations handle TLS connections for your CloudFront distribution. So one of the great security benefits of using CloudFront is that you can configure minimum TLS level accepted by your CloudFront distribution. You can select a security policy in the distribution configuration that requires TLS 1.2 or 1.3, and that's what we're showing in this screenshot. That would protect your user's data as it traverses untrusted networks. So for example, if your users are transmitting data over a, let's say, coffee shop Wi-Fi or some other untrusted network, this would provide additional protection. Okay, so now that we have protected the perimeter, we'll focus on control of the network traffic where our API is hosted inside of the AWS regions. So how do we get that additional control? That's what our next session is all about. Gaining greater control of networking. We have learned that serverless comes with a baseline of security defaults. We added perimeter protection. So now it's time to dive into the serverless networking inside of the AWS region and how we can tightly control network flows inside of the region. We typically implement those network controls inside of VPCs. So to get more control of Lambda function traffic, we need to do something first. Now you can attach AWS Lambda functions to your VPCs. Why would you do that? Well, the truth is Lambda functions always operate within a VPC. And by default, those that's inside of the Lambda service account. Lambda service operates AWS accounts and VPCs in the same way AWS customers do, and then they apply a number of service controls on that networking traffic. However, if you want to gain additional controls and apply your own controls, your own rules, well, then you can attach your Lambda function to your VPC. So AWS Lambda service will attach a network connection inside of your VPC, creating an ENI. Note that Lambda service will create one ENI per combination of security group and subnet. So if you were to change, for example, security group, it will have to take its time to create another ENI. All traffic originating from your Lambda function will follow all the routing and security controls that's implemented inside of that VPC. Let's look at how we can depict that now on that architecture diagram. Okay, we have now added a VPC with a couple of private subnets to the architecture. Now we're only showing one subnet for clarity. Those subnets have their own NACLs and their own routing tables. And in this particular example, we do not need any public subnets, and it will be obvious why we do not need any public subnets. This is entirely private VPC. But we'll dive into networking controls and make that really obvious. Now we have Lambda functions inside of the VPC, inside of that private subnet. We haven't discussed how security groups should be used with Lambda functions that are attached to VPC. So we'll dive into that into more detail here. Every network interface that's used by Lambda functions has one or more security groups attached to it. If you recall, Lambda functions do not accept any inbound traffic, so we don't need to open up any ports on it. So this is an example of table of security group rules, and notice that no inbound rule is required. But you do need to open up outbound traffic to resources that your Lambda function communicates to. Okay, now we have applied security group rules to all of the Lambda functions in our VPC. Well, and now we have a next task. How do we enable that function 1 to communicate to that Amazon Aurora database that's provisioned within the same VPC? Well, in this case, Lambda functions will work just like any other resource inside of your VPC. Lambda function 1 will make outbound connections to the database. So it needs no inbound rules, but it needs outbound rules, opening traffic to the database. And the database needs to accept incoming connections from that Lambda function. Okay, so now Lambda function 1 can communicate to the database. But what about Lambda function 2. It needs to push messages into an SQS queue. SQS service is in the same region, but notice that its endpoint is outside of the VPC. So how can we connect to that SQS service? Well, many AWS services are similar to Amazon SQS, and they have endpoints that are outside of VPC. So to connect to them, you can provision interface VPC endpoints. An interface VPC endpoint provisions inside of your VPC, and you will actually see its network interfaces in the selected subnets, and you will have to assign it security groups. Now, in the background, so the interface VPC endpoints uses technology called AWS Private Link to establish connectivity to different AWS services, and in this case, this would be Amazon SQS. You will need to configure security groups, just like with all other resources in VPC, to allow network connectivity. Now, keep in mind the direction of traffic. It's always outbound from Lambda function, and it's always inbound on the interface VPC endpoint. Now, VPC endpoints give us an additional control layer, and this is VPC endpoint policy. This is an important control, so let's dive a bit deeper. All right, so what are IAM policies doing in a network security presentation? I know this is network security focused presentation, but let's look at how policies can be used to enforce least privilege principles. VPC endpoint policy is applied on requests made by resources inside of your VPC out to AWS services, and you can get very granular if needed. In this particular example, we are allowing communication only to a very specific SQS queue. You can pair VPC endpoint policies with resource policies, and in this case, we have a resource policy applied on the queue that allows traffic that went through your endpoint to talk to this queue. As you can see, these policies provide additional and very important layers of control that go beyond the networking rules. All right, so Lambda function 1 and 2 are connecting to their respective AWS services, but what about function 3? It needs to insert some new records inside of the DynamoDB table. So how would we connect to DynamoDB? Is it similar to SQS? Well, let's take a look at that. We do need an endpoint in our VPC, but to get to Amazon S3 or to Amazon DynamoDB service, you'll need a special type of endpoint. It is a VPC gateway endpoint. Now notice the VPC gateway endpoint is not shown inside of a subnet. That is because gateway endpoints do not use network interfaces. Instead, they rely on route tables that direct traffic to the service endpoint. When you associate a VPC gateway endpoint to a route table, it adds a prefix list, which is basically a managed list of IP ranges used by either DynamoDB or S3. There is something important to note about the security group associated with Lambda 1, though. Its outbound rules must reference the same prefix list to enable the Lambda function code to make calls to the DynamoDB service. And VPC gateway points also support endpoint policies to give you even more granular control of calls to DynamoDB or S3. Now, in this example, we are allowing access only to a very specific table in our account. Okay, let's get back to our serverless architecture. Okay, now that we have established a great deal of control of network traffic, we added perimeter protection to filter out unwanted requests before they even reach our resources in the AWS region. We attach Lambda functions to the VPC and establish really tight controls on network paths between resources inside of the region. Okay, now how do we gain visibility into the network traffic in this architecture? Well, let's discuss that in the next section. Improving observability. Let's understand the network traffic flowing through our application. How do we get more visibility into the network traffic? A good place to start again is at the perimeter. AWS WAF can send full logs to Amazon Kinesis Data Firehose service. These are comprehensive records of each request that comes through. So let's look at one example of that. WAF full logs contain comprehensive records of all requests, as I mentioned, but they'll tell us if they're blocked, allowed, or simply counted. If WAF is blocking a request, it will generate a 403 message to the client And you can customize this if you're using CloudFront. But on the other side, on the back end, the WAF logs will contain full details of the request. And those will include things like all the headers, IP address of the caller, and WAF action details. So those WAF action details will include which WAF rule was triggered, if the action was allow, block, or simply count, if you're just trying to test out a new rule. Now, for certain types of rules, such as SQL injection and cross-site scripting, AWS WAF logs contain details of specific data in the request that match the rule. Now, we're looking at one example here, and where a part of the URI in the request matched a SQL injection pattern. All right. So now that you have recorded all these logs to analyze the data, it can be aggregated to data firehose and then routed to S3 Splunk, or you can send WAF logs to Amazon Elasticsearch Service. And Elasticsearch Service has a built-in integration with Kibana, and Kibana can be used to build out dashboards for analysis and visualization. And there's a great blog article here that walks you through step by step on how to build out a dashboard, and that will provide you all the details behind the request. So let's get back to some other log sources. Okay, now we have visibility at the perimeter. But what about resources inside of the region? Amazon CloudWatch service aggregates a variety of metrics, including network traffic metrics. CloudWatch logs aggregates both application and network logs. And some of the network-related sources for logs are VPC flow logs and Route 53 resolver query logs. So how do these log sources help us gain visibility into network traffic? Let's dive deeper a bit into those. So how can we gain info about network flows? VPC flow logs can aggregate information about network traffic for all network interfaces inside of your VPC into CloudWatch logs, and they'll capture data about network flows such as source, destination IP addresses, ports, protocols, and specifically for security experts, it's really important to understand if the flow was accepted or rejected by security groups or by NACLs. We can also dig into DNS logs in our VPC. And Route 53 Resolver provides logs of all DNS queries in your VPC, giving you that really added insight about the applications and how they're operating. Again, you can aggregate all those logs into CloudWatch logs. CloudWatch itself has a feature called CloudWatch Logs Insights. And CloudWatch Logs Insights allows you to perform advanced queries and perform visualization of data in those logs. And what you're looking at on the screen is an example of visualizing these DNS logs. Okay, let's get back to our serverless architecture. Now, we're gathering logs and we're analyzing data about incoming requests, traffic flows, and DNS queries. But how will we know if there's some unwanted activity that we really need to react to? Okay, well, the next group of services will help us identify threats and respond to them and potentially investigate as needed. These services are Amazon GuardDuty and AWS Security Hub. Let's dive into how these services can help us. So how do you find out if there's a threat to your application or to your environment? Well, Amazon GuardDuty is a service focused on identifying threats to your AWS environment. It ingests telemetry from multiple sources, such as VPC flow logs, DNS logs, and CloudTrail, then applies machine learning and data from threat intelligence sources to alert you if there's any threats. GuardDuty has access to those logs, even if you haven't enabled delivery of, let's say, VPC flow logs and DNS query logs. You can actually access those logs through AWS Backplane. When GuardDuty identifies a threat, it creates a finding with all the important details about the attack, and then it publishes that data to Amazon EventBridge. And so you can integrate that with your custom SIEM, or maybe with one of the other AWS services. One of those closely integrated AWS services is AWS Security Hub. Now, as the name implies, this is a one centralized location to surface security data that comes from multiple AWS accounts, multiple services, and even third-party partner products. It provides really a comprehensive view of your security posture in AWS and helps you check your entire environment against industry standards such as CIS benchmarks, PCI DSS, and even against AWS security best practices. As you can see, Security Hub ingests findings from GuardDuty and from other security services, for example, from Macy and Inspector. And it's all done in a standardized AWS security finding format. Your security analyst can then review this data inside of Security Hub, and when needed, they can take additional action. So this is what our architecture looks like with greater observability at every layer, from perimeter to VPC network traffic, DNS logs, to threat detection, and even reporting. So now it's time for our final section. All right, we had fun diving into various aspects of network security for serverless workloads, but let's take a look where we started and where we got. Here's where we started. It's a typical and fairly simple serverless architecture diagram. We'll learn that it actually comes with a really solid base of security defaults. For example, a micro VM-based isolation model for Lambda functions. And then we took things to a whole new level. We added perimeter protection measures, we attached Lambda functions to VPC, and established least privilege network traffic routing. We gained visibility into the traffic at the perimeter and inside of the VPC, and then we set up automated threat detection, reporting, and even supported investigations. Now, I hope that by now you understand every element on this diagram and the role it plays in a highly secure serverless architecture. With that, I would like to thank you for attending today's session. Please fill out the feedback form and let us know how we're doing. Thank you again.